So here we're given the system equations where we have one quadratic, the other is a straight line, and we're told that they intersect exactly at one point, which means the straight line is tangent to the graph of the quadratic. That means if we were to solve for the x value, there will be only one real solution, and that's the corresponding quadratic. So if I rewrite this, this is our quadratic. Now we know that in general, if you have a quadratic ax squared plus bx plus c equal to 0, it will have a double root or just one solution when the discriminant is 0. So if I apply that here, minus 4ac, a is 2, and then c, so that's the condition. So 24 times 24, 4 times 2, this I'm moving to the other side, divide by 8. So I get 72 is 64 minus a, which means a is minus 8. So that our straight line is y equal to 3x minus 8. Now, of course, minus 8 is not the answer. That is, of course, the trap answer. So once you know both the equations, you can just graph them. And that's what I've done here. And you can read off this point, which is 6, 10. And they were looking for the x-coordinate of that point of intersection. So that's 6. And then that's answer choice C. Now, some of you might know how to find the slope of a straight line at any point on this quadratic function from calculus. The ones who don't know, I mean, obviously can't use this approach, but the slope of the tangent line would be 4x minus 21. And what we're saying is it needs to be equal to the slope of that straight line, which is 3. And what point is that going to happen? 4x equal to 24, x equal to 6. So that, obviously, you know, for the digital SAT, they're not assuming that you know this, but for students who do, you can also approach it that way. So the answer is choice C.